developers are there. Everybody that develops all the programming projects and web platforms and everything are all there. And there's beginning stuff and there's advanced stuff. So check it out if you're interested. If you do go to it, it's worth extra credit. Anyway, so we're down to this stuff. All right, so let's talk about HTML. HTML is called a markup language. It is not a programming language. It doesn't have branching, looping, and testing. All it does is mark up things to say how they should look. That's why HTML was the world's best box of crayons. I have no coordination. I couldn't draw anything, but you can make a beautiful web page by using tags. So for most people love it. You use things like use these less than and greater than signs to make tags. So you put in header tags, the text gets bigger. You put in break, it makes a blank line. You can make things italic. You know, you can format things. You can put in images and all that good stuff. But you can't do calculations or programming. It doesn't have any loop. It doesn't have any variables that can count up to 10 or anything. You just say what things are going to look like. It's just a way to control the appearance of things, which is cool. So Perl is a real language. This is particularly designed to handle input of text data and formatting it, which is very painful in scientific languages like C and Fortran. If you have some kind of data with 10 columns and 5 fields and there's numbers and letters, you have to specifically specify all those things, whereas Perl can just input a whole file of data with just one command. It's designed for that. Practical extraction and reporting language is developed by Larry Wall. All programming languages seem to come from one guy that is then like the guy that watches over it and decides how everything should be to keep it all consistent. And so Perl doesn't have any libraries, or it isn't as structured as C. You can just say print something and it prints it. These are all comments with the pound in front of them. You don't have to have a main routine or anything. Perl can be run in an interpreted mode where you just type one command and it takes effect right away instead of having to compile it. And you can format things very much like C with printf. You could say characters and numbers and such and specify how many places to show. It has some weird things. You put sub in front of function names, and all variables begin with the $sign, even though they're not necessarily money, which always irritates me because it's a strange way to write. And the ampersand character is how you call a subroutine. So this thing has a subroutine called speak, and this ampersand calls the speak, which then prints a word. This defines the word, and it goes down there. So I mean, it's looks different, but anyway, it can, of course, all programming languages have the same ultimate capability. They can all solve these NP-complete problems. Anything with a clear set of instructions can be solved, and that's all. Yeah?
So subroutine is like a method or a function?
Yes, that's right, yeah. And all modern languages have them. Originally, they were unstructured languages that didn't even have subroutines. All you had was goto. And that was for the birds. It was impossible to maintain the code and to adapt the code. So that structured languages had subroutines, so you could break your code into little segments and test them and reuse that code. And these are all in that category. So then there's a for loop in Perl that looks kind of like a C for loop, really. It has that for, the thing in parentheses, which has several statements that make the loop. Here's a test. If IQ greater than 7, print something else, print something else. That looks pretty much like all the other languages look pretty much the same there. And then the next generation of languages was object-oriented, where you make more abstract data structures. Instead of just having variables and functions, you can define a more complex structure. And that's the modern one, C++ and C# and Java and Object COBOL and stuff. So you define this thing called a class, which is a more abstract quantity than a variable. So you can define something like an employee, which is your information about an employee, and then you can have attributes and methods. The employee has attributes, which is data, like a name, social security number, address, and then it has methods, like a method to hire a new employee, to promote an employee, to fire an employee, things like that. To put an employee on vacation or something, you have these functions. So you define a class in C++, define a class employee, and it has these attributes, and here's one of the methods. And there's also a method that creates an employee and a method that destroys an employee object. And then you can define other things, like you can define a visitor object that comes from the employee class. So it gets all the attributes and methods of the employee class plus others that you add to it. And that's the higher level of abstraction that really helps you solve real world problems. And inside there, these actual methods like get employee just have the old fashioned kind of code in there really. But this makes it possible to manipulate more abstract quantities. Yeah?
Where does this all live? Do they live in the same file, your class, your code, your compiler?
Usually a whole bunch of files. Like if you take apart an Android application, it's about 100 files in 10 folders. They're all sprawled all over the place.
So it's not just one particular language. Let's say you download words.
Right.
It all live in that particular file.
Oh no, it's all it's a tons of modules all linked together. If you actually see the source code, it's a giant sprawling tree structured directory of many things all dashed together. It's zipped up into one container, that's all. But it's actually many little chunks all put together. And typically for something like Word, it's actually a whole bunch of third-party things written by someone else, purchased and put in, which is how you do it. You buy a bunch of code and you only write a little bit, if you're making a commercial product typically. Android things are really that way. So Ruby is a language recently invented in Japan. Very nice, kind of like C, very logical. Metasploit is written in Ruby, and the Metasploit attacks are written in Ruby. And it's, you can see the colon, it's object-oriented. You define a thing called a class, Metasploit. Then you have ranking and so on. Then you have methods and such, license, this. They're actually very readable. If you look at the actual source code for Metasploit attacks, they're very easy to read and understand. And some of them are so great, like there are network attacks where they just take a packeted Wireshark that causes the problem and they just copy the hex and put it right there and then just write a little Ruby around it to send that packet. You know, it's really quite easy to read. That's why people love it. Ruby is not baffling like C tends to be baffling and assembly tends to be very baffling. Ruby is almost like pseudocode. It's really pretty easy to read. And then there's other crazy languages like law code. This one's after lawcats. Yeah, and you can learn law code where I has a var, I'm in your loop. Everything starts with hi, everything ends with k thanks bye. And there's even a lawcat interactive tutorial. If you want to learn lawcat, you can go here, Ken has law code. And you can now practice law code. Put up here, visible is what print is. Visible, fluffy. Submit code, and you are done with challenge. And on you go. You have a tutorial. You can learn law code. So you can do any language works. And this one's made obviously as a joke. The next one is actually a little different than a joke. It's kind of so you can learn it here. The other one to hear about is BrainFuck. BrainFuck is one of the category of esoteric languages. Normally the point of a high-level language is to make something that looks like English so it's easy to write. But there are some people who decided to go the other way. They said, how baffling could you make a language? And so this language, the original computer, which was never built, was the Turing computer. And it was a really weird thing. Before there was any computer hardware at all, Turing invented this out of mathematical abstraction. And what it was like a measuring tape. You just had a line of cells that could each contain 1 byte. And you had this thing that sat on it like a snail. And all it could do was change the number under it, or move to the right, or move to the left. And you'd ratchet back and forth like a snail crawling back and forth on here, changing the numbers, and that was his computer. And he proved mathematically that computer could solve a certain category of problems called NP-complete and started this whole thing. And when we actually built hardware, it was totally different. It didn't work that way. BrainFuck works that way. So there are only 8 commands, and every one of them is just a punctuation mark. So this increments the thing to the right, this increments the thing to the left, this increments or decrements the thing that you're sitting on, and this one moves to the left, this one moves to the right, so you hop around like a snail going around on this tape, and you change the bytes, so eventually you make something happen. So this is Hello World in BrainFuck. And the whole point of this is that this is almost impossible to understand. But if you're clever enough and you work hard enough, you'll finally understand. This does something like take the byte underneath the cursor and decrement enough times to turn it into H. Then move to the right and make this one E, and something like spells out hello or something. That's the idea. And you can do anything. And there is a BrainFuck compiler, and there's a BrainFuck interpreters. And the last CTF we did a couple weeks ago, there was a puzzle which was like a bunch of hexadecimal, and you would decompile it and it would turn into BrainFuck. And you had to go find a BrainFuck interpreter to run it to turn into the next thing. So you can totally write things in this, but you could say why, but you have to not think that way. But the point is, of course, you really understand how computers work when you're able to work in a language like that, where they have not helped you at all. In fact, they made everything as difficult as possible. You must really know what you're doing. And when I was in grad school, there were people that did this. VI is a text editor for Linux, and it has these keyboard commands. There was a guy that was teaching celestial mechanics at my college where you had to calculate the orbits of planets and moons. And the celestial mechanics guy said, write a program that will calculate the orbit of the moon. They said, do you care what language we put it in? And they said, no. So one guy wrote it in VI. He made a text document that would somehow use the text commands to calculate the orbit of the moon. Because it has like variables, you can count how many times you're going to search and replace something, and you can increment and subtract. You need somebody to make a multiplier and somebody to handle a floating point, and this is really doing things the hard way. But of course, that shows how much you know. Anyway,
there's no clicker question.
There are.
On this.
On what? Oh no! I didn't put BrainFuck on the quiz. It's not in the book. No, I added them just for interest. But yeah, no, I didn't put BrainFuck or law code on the quiz. They're not in your textbook either, which I think is an omission. And I even like a technical review of the next textbook, and I forgot to tell them to put that in. I should have. Anyway, so no, but the rest of it is fair game. I mean, that's a fair yes. You do not need to learn BrainFuck to pass the test. Oh, that would be pretty awesome, but that would be in the other department. We're not really supposed to be teaching programming here. All right, so I got a few more iClickers. So, which of these is not a programming language?
What about Scala?
What about what?
Scala language?
Cal?
Scala.
Gal?
Scala.
Gallon?
Scala.
Kala. I never heard of it.
No,
Scala.
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 Oh, I don't know. I've never used it. I've heard the word at least. But I don't know. There's hundreds of languages. When I all started years ago, we used to talk about which language is going to win. We thought there would be one winner, and that didn't happen at all. There are hundreds of them. And if you're a web developer, you typically know like 50 languages. It's nuts. But it turns out that it really helps to use a language that's specialized for your task. So you do in the task, you use the right language. A typical website has got like 15 languages. And every time you switch from one language to another, you often create security vulnerabilities. So it's kind of crazy. In the beginning, in the 70s, we all thought that everyone would settle on like Fortran or BASIC, and that would be it, and all the others would go away. But that totally is not how that didn't how it turned out. Yeah.
Giving me red.
Yeah, it gives you red because the clock it's not listening anymore. That's because it only that's right. All right, so that's HTML, of course, the thing that is not a programming language. Which one of these is interpreted, not compiled? All right, I guess I'll quit at 30. All right, and that's Perl is often interpreted. By the way, Python is too often. You can compile them, but you usually don't. You usually just run them as scripts, so they run fast. You don't need to go through a compiling step. Interpreted languages run much slower than compiled languages, but they're easier. You just type the commands, and it just does the commands you type. All right. All right. Which one of these puts dollars in front of all the variables? PHP does it too, so if I would stick to one language all the time, my life would be a lot easier. I keep making mistakes because I'm switching language to language, and I keep forgetting things like this, like whether you're supposed to use the stinking dollars or not. So I do what everybody does. I Google Stack Exchange and copy their code for everything I'm doing. Practically everything I write is just stolen from Stack Exchange and patched together, and almost everybody does it that way. So that is Perl again. Good, all right. And on it goes. All right, which one's object-oriented? Guess I can quit at 25. Looks like I pretty much got the answers. All right, and that is C++. There's a version of Perl that's object-oriented, but it's not the most common kind. C++ is there to add the object-oriented stuff to C. There's actually a very interesting blog post that seriously said that C++ was a joke They thought it was so screwed up nobody would ever actually use it. And this is pretty easy to believe when you learn C++, because C is so beautiful and logical and mathematical and perfect, and C++ is just like a pile of garbage thrown on the table. It's just amazing. It totally violates all the beauty of C. But anyway, it is really for real. Which one is mainly for file input and output? All right, I'll quit at 25. All right, and that's Perl again. That was practical extraction and reporting language. It's optimized for that task. All right, so I'll stop the recording and then I'll see who won the iClickers, and then I'll go to the lab and help anybody who wants to help there. 7B.